All right, so here we are. We've got your Unit 4 study guide on covalent bonding. I want to make sure that before you even get started that you make the couple corrections that we did in class, but I want to make sure that you also know if you have a study guide that says C4H10N, please cross that off and make sure that it says C4H11N. Unfortunately, there was a little bit of a typo. It is still possible, but I realized it was much harder. And the other correction you should do right down below here. I made this problem also a little bit easier. So right down here, you had a different number, is something like 24. Change that to 23.89. This number right here, also, please change. You had a different number, something to the sort of... I think it was something like 5 or something. Please change that to 2.93, exactly what I have on this new version. And you had something like 17.965. Please cross out your number you have and write 20.96. So that is your first correction. Make sure you make that correction on your version as well. So we're going to get started. We're going to do number one very briefly. Your brief summary needs to be 3 to 4 sentences. I'm not going to give you the full answer, but remember, you've got 3 things. You've got 3 things that you can actually, excuse me, I just got a little bit of marker on my hand there. 3 to 4 sentences. You've got 3 resources that you have. You have one of your resources is the TED Talk video guide with the Penelope Jagaser Chaffer and Tyrone Hayes video that we watched in class. The other resource that you have is also the notes that we took in class about endocrine disruptors. And then the third resource that you have is the reading on endocrine disruptors. So the general gist is that you've got endocrine disruptors, remembering that the endocrine system is your hormone system. And where are they found? They're found in a variety of different places throughout your body, anywhere from your reproductive organs to the thyroid to pancreas. I mean, really anywhere you could say. And how do they affect the body? There are many different ways that they can affect the body. Anywhere from cancers to maybe having eggs inside of testes or there can many different things. You have many resources. And what can you do to avoid them? Really, the main thing that you can do to avoid them is to not be using plastic. And also, and where are they found? They're found in a variety of different products, everything from BPA to BPDDEs, or you can also find them in plastics and furniture, etc., etc. So they're found in the body, as I mentioned before, but they are also found other places throughout. You can find them there. So that's your gist. That's as far as I'm going to go in there into detail on number 1. I am going to go into detail more into number 2. So number 2A, my biggest tip I can give to you is every time that you have your molecular formula, the first thing you do is you put the first atoms that are in your molecular formula, unless it is hydrogen, first. So we're going to put the 2 hydrogens together, I said hydrogens, the 2 carbons together, and then you've got 2 hydrogens. I'm going to I don't want to cheat on this carbon, so I'm going to put that other hydrogen on the other one. That's my biggest tip. Make sure that everything's evenly distributed. Then you've got a chlorine. I'm going to put the lone pairs of chlorine on the atom. Notice that your 1 electron there that chlorine has is going to share with that carbon. And then we've got chlorine here. So, chlorine is going to share with the carbon. So now we've got the honk rule. We've got hydrogen has 1 bond, hydrogen has 1 bond, chlorine has 1 bond, chlorine has another bond. So here we are, but check this out. Carbon, it only has 3 bonds. If you end up putting together a molecule, the biggest tip that I can give you is that if you have a molecule and you don't have something that follows that honk 1, 2, 3, 4, reminding you that honk 1, 2, 3, 4 means that hydrogen will have 1, oxygen will have 2, nitrogen will have 3, and carbon will have 4. Carbon is not following that rule. If I do a double bond between both of those carbons, that would then satisfy the honk 1, 2, 3, 4 rule. All right, if you have questions in class, please make sure you refer to them to me as soon as you can. So here we've got carbon. Here's our first one. I'm going to distribute those hydrogens along our carbon. And then we've got a bromine. Make sure that you are including your lone pairs of electrons. And double check, making sure everything has its follows the honk 1, 2, 3, 4 rule. We have the atom. We have the molecule. Next one, you've drawn this one a handful of times. You actually drew it the other day. We start with carbon. We've got 3 hydrogens. Then we've got an oxygen. We've got an oxygen here. Make sure you put your lone pairs on your oxygen, and then you've got a hydrogen. Double checking, making sure you've got every carbon has 4 bonds, all oxygens have 2 bonds, and all hydrogens have 1 bond. That's going to be your clue here. Your easiest ones are going to be stuff that has single bonds. What's going to be tricky is when it starts to double bond. So here, going to start the same idea. I've got carbon, I've got carbon. You're going to have those 2 carbons bonded to each other. And then, similar to what we did with part A, is we are going to take an iodine, and we're going to put an iodine on each one of the carbons. Notice that I did like a little bit of a spacing it out. You could do it up here. I could erase that. I could put it on the side. Really, it does not matter as long as you have each carbon having an iodine at this point. So this iodine, it only needs 1 more bond because, again, it's in that 7th group. So you've got 1 bond here, you've got 1 bond here. But check it out, this carbon only has 2 bonds. How many bonds do we need to have? Again, carbon needs to have 4 bonds. So I'm going to draw another line here. Now both of these carbons, this carbon has 3 bonds, this carbon has 3 bonds. Still not enough bonds. Remember, you can do more than just double bonding. You can also do a triple bond. So now this carbon here has 4 bonds, 1, 2, 3, 4. This carbon here has 4 bonds. So then you have your molecule. It is done. Moving on to the last one, or excuse me, the second to the last one, we've got a nitrogen bonded to a nitrogen. And I'm going to do the shorthand. So we've got 2 nitrogens. So we've got 1 bond between them. But how many bonds does nitrogen need to have?